Hi folks, it's Dr. P. The purpose of this video is to get you acquainted with the shift register that you built as part of Lab 10. The shift register is a very important logic device. It has several different features. They generally are capable of loading data, holding data, and then shifting in one or more directions. This register will be capable of loading data, holding data, and shifting it in one direction. It's going to be a 3-bit register. So restricting a little bit about what this is able to do, in other words, shift in only one direction and only have 3 bits of memory, is just to kind of make it a little bit simpler to build in one lab session. So I'd like to show you the different capabilities, which I have built already on this breadboard. First, I'm just going to zero everything out. So the first thing that it can do is load data, which is to say I put information on a dip switch and I press a button and that information gets loaded into the outputs. And I'm just representing the outputs with LEDs. As long as I don't press any button, we're holding data. So that's that kind of latch or hold functionality. And then there's a shift button, which will take the data and kind of shift it in this direction. So it's going to kind of move downwards, so to speak. So what we're going to do is we're going to build it, and we're going to break it into 2 parts. The first part is going to be just getting that load capability. The second part is going to be integrating in the shift capability. And once you've got both of those, then you're good to go. Ready? Let's do it. All right, so what we have now is a functioning parallel load capability. What happens is I can change the inputs on the dip switch, and when I push the load button, those inputs will go through to the LEDs. So these are the 3 outputs of the 3 registers. So whatever combination I have on the inputs is going to just pass through to the output. So how I'm achieving this is just using our JK flip-flops as a D flip-flop. Meanwhile, they're being clocked with the combination of the actual clock signal from the function generator and with the load button. So essentially, what's happening is when the load button is pressed, the clock signal will come through to the flip-flops, and when the load button is not pressed, the clock signal is being inhibited. In other words, I have a low output value, so I'm going to just have a 0. So there's no falling edges for the flip-flops to have their outputs updated. So this is just half of the functionality, but it's still good because you know that the presets and clears on all the flip-flops are correct. You know you've got the output and input pins correct. You know you've got your dip switch right. You know you've got the push buttons connected properly. So the next part that we'll do is integrate that shifting capability. Let's go ahead and build that now. Alright, so what we've done now is include the shifting capability. So what we've had to do is change the inputs to our JK flips and also slightly modify the clock signal. So I can do what I did before, which is put some inputs on my dip switch and press the load button, and I get that parallel load. And then I can also press the shift button, and we can see that that data is going to be moving from A to B, B to C, and C kind of off the face of the earth. So what we had to do here was just, like I said, change the input values, because how this works is if the load button is pressed, the dip switch inputs should go through to the outputs, or if the shift button is pressed, the previous output should go to the input. So we can kind of use Boolean algebra to figure out what expression to use on our JK inputs. The next thing that we've had to do is to slightly modify our clock signal. So it previously was just the load and the clock, but that doesn't account for, I need the outputs to update if I have the shift button pressed. So what we want to happen is we want the clock to be activated, at least the function generator clock to be activated with the load button, or I want my shift to kind of act like a clock. So now this is not a universal bidirectional shift register, but it's capable of doing a single directional shift, and it's able to essentially load, hold, and shift in one direction. So this is a pretty big step of the way towards the functionality of what we'd get with that 74194, that universal bidirectional shift register. And hopefully you get a better picture of how a universal shift register works by building one yourself. All right, folks, that's all there is to this. Until next time, stay well.